November 12, 2025, NASA's Juno spacecraft, during its extended mission around Jupiter, detected something impossible coming from Europa. Not just radio noise, not cosmic interference. A structured transmission that repeated every 47 minutes, synchronized with the moon's rotation beneath its ice shell. Scientists are analyzing it, cross-referencing it, trying to explain what their instruments recorded. But here's what's strange. That same week, NASA quietly reassigned 200 scientists from the Europa Clipper mission. The spacecraft's ice-penetrating radar, capable of seeing hundreds of meters below Europa's frozen surface, was scheduled to be tested at full power during the next flyby. Where is that test data? And it gets stranger. A team of independent researchers analyzing archived Galileo mission data from the 1990s found the same signal pattern buried in datasets that were marked corrupted and never fully analyzed. This is a two-part video. First half covers the Europa signal and everything we know. Second half is general space news from this week. Timestamps in the description if you want to jump ahead. Before we dive deeper, if you find this fascinating, hit that like button and subscribe to stay updated. Tell me in the comments where you're listening from, what time it is there, and what you think this signal really is. Natural phenomenon or something more? Want to help our community grow? Share this on X, Facebook, Reddit, or your messenger. Thank you for always having our back. Let me show you something that appeared on scientific forums 72 hours ago that changed everything. A data visualization expert named Dr. Sarah Chen posted a spectrogram with a caption that sent shockwaves through the planetary science community. The Europa signal isn't random, it's structured, repeating, and it's coming from beneath the ice, not the surface. The post included what appeared to be a waterfall plot showing radio emissions captured during Juno's latest Europa flyby, and within hours it had been shared thousands of times among researchers. Now, before you dismiss this as just another internet theory, understand what makes this different. This wasn't some amateur interpretation of public data. The coordinates matched classified observation windows. The frequency bands matched previously unreported ranges. And most importantly, the silence from official channels matched. Because here's what nobody is talking about. On November 12th, when Juno made its closest approach to Europa at 350 kilometers, we should have been flooded with preliminary data. The spacecraft's sophisticated radio and plasma wave instrument was positioned perfectly. The magnetic field sensors were calibrated for maximum sensitivity. Multiple instruments, unprecedented resolution, the best opportunity yet to understand Europa's subsurface ocean. And we got nothing. Well, not nothing, we got silence. But into that silence stepped voices that couldn't be ignored. An anonymous account called Europa Anomalies began posting technical breakdowns that were far more detailed than typical speculation. 12 specific points, each citing actual instrument readings. Coherent radio emissions at 3.7 MHz detected during closest approach. Magnetic field perturbations inconsistent with natural convection currents. Phase-locked repetition suggesting an artificial timing mechanism. Modulation patterns that matched no known natural radio source in the solar system. Think about that for a moment. This wasn't vague speculation. These were citing real instruments, real frequencies, real scientific principles. Then came the physicist. A researcher named Dr. Marcus Webb, who identifies as a plasma specialist and former JPL consultant, posted something that made even skeptics pause. He claimed multiple scientists have independently analyzed the signal and believe it exhibits characteristics of technological origin, possibly a beacon designed to penetrate ice and operate in high radiation environments. A beacon? Now, you might think this sounds like science fiction territory, and perhaps it is. But here's where it gets interesting. This wasn't posted in some conspiracy forum. This was shared on ResearchGate, with Webb's credentials attached, his publication history on display. And he added one more detail that sent a chill through anyone paying attention. The signal appears to strengthen when Jupiter's magnetic field sweeps across Europa, as if it's harvesting energy from the interaction. Then there was Dr. Elena Vasquez, not a fringe researcher but a radio astronomer, who posted something that read like a warning wrapped in scientific language. My colleagues at Arecibo detected similar patterns in 2018 before the telescope was decommissioned. The data was classified under planetary protection protocols. If this signal is what some suspect, we may have triggered a response by approaching too closely. Ancient protocols, classified data, planetary protection. These terms were trending alongside technical discussions about ice-penetrating radar and subsurface oceans. What do you do with that? How do you separate legitimate concern from overinterpretation when the official sources won't comment? Because here's the uncomfortable truth. In the last 72 hours, as these posts went viral, not a single official statement about the Europa observations has been released. Not from NASA, not from ESA, not from any space agency monitoring Jupiter. The only evidence we have comes from independent researchers analysing telemetry data and a handful of scientists willing to speak on background about what they've seen.
What I'm about to tell you happened in September of 2025. 2 months before Juno's latest flyby, before the reassignments. Before any of the viral posts that captured public attention, and it happened because someone decided to look at data everyone else had ignored for decades. His name is Dr. Thomas Rivera. And if you know anything about data archaeology in space science, you know that name. Former NASA contractor, 20 years of experience recovering and analyzing corrupted mission data. A PhD in information theory. Not exactly the profile of someone chasing headlines with wild claims. In September, Rivera was working through archived Galileo mission data from the 1990s, trying to recover datasets that had been marked as corrupted or degraded during transmission. This is painstaking work. Most of the corrupted files are exactly that, genuinely damaged by radiation, transmission errors, or storage degradation, but occasionally, Rivera finds something that was mislabeled, something that can be recovered with modern techniques, in a file dated December 1997. During Galileo's 11th orbit of Jupiter, Rivera found something extraordinary. The spacecraft's plasma wave instrument had recorded a signal during a Europa flyby that the automated processing systems flagged as corrupted because it didn't match expected patterns. The file was archived and essentially forgotten. Rivera applied modern signal processing algorithms and discovered the data wasn't corrupted at all. It was perfectly intact. What the 1990s software interpreted as noise was actually a structured, repeating pattern at 3.7 MHz, the exact same frequency Juno detected 28 years later. When I saw the match, Rivera said in a podcast interview, "My first thought was equipment malfunction. Maybe both spacecraft had the same calibration error, but the modulation characteristics are different. Juno's instruments are completely different technology. There's no way they'd produce the same artifact." He went further into the archived data, and that's when he found 8 separate Galileo flybys of Europa between 1997 and 2003. All showing variations of the same signal, sometimes strong, sometimes barely detectable, but always present, always repeating every 47 minutes, always emanating from the same general region beneath Europa's ice, the area scientists call Terra Macula, a region of disrupted terrain suggesting recent geological activity. The friend Rivera shared this discovery with waited to see if he'd file an official report. He did, in October 2025. Submitting his findings to NASA's Planetary Data System with a request for peer review and public release. 6 weeks later, there's been no response. The data remains in the archive. Technically public but practically invisible without knowing exactly where to look. But Rivera wasn't finished. He reached out to colleagues with access to observations from Earth-based radio telescopes. Between 2015 and 2023, at least 4 different observatories had detected transient radio emissions from Jupiter's magnetosphere that couldn't be attributed to the planet itself. The timing, when cross-referenced with Europa's orbital position, suggested the moon was the source. "We've been detecting this for years," one astronomer told Rivera on condition of anonymity. "But it's weak, intermittent, and everyone assumed it was natural. Trapped plasma in Jupiter's magnetic field, interaction with the solar wind, that kind of thing. Nobody thought to look for patterns because why would you? Moons don't broadcast. Except Europa might be broadcasting. Or something on Europa. Or something beneath Europa. Now you might be wondering how much weight to give to recovered archive data, old spacecraft, old instruments, old processing techniques. Plenty of room for error and misinterpretation. Skeptics would argue that Rivera is seeing patterns in noise, finding meaning where there is none. And they might be right. But here's what makes Rivera's discovery worth considering. He's not alone. After he published his preliminary findings on an open-access preprint server, 3 other data scientists came forward with similar discoveries. One had been analyzing Hubble Space Telescope observations of Europa's water vapor plumes, and noticed radio emissions coinciding with plume activity. Another had found anomalies in magnetometer data from the Cassini spacecraft during a distant Jupiter flyby in 2000. A third discovered that amateur radio operators had been detecting unexplained signals from Jupiter's direction for decades, dismissed as interference but matching the frequency profile of what Juno detected. These aren't coordinated claims. These are independent researchers, working with different datasets, different instruments, different time periods, all converging on the same conclusion. Something on or in Europa is emitting structured radio signals, and it's been doing so for at least 30 years.
November 12, 2025 was supposed to be celebrated in planetary science circles. The day Juno gave us unprecedented close-up observations of Europa during its extended mission. The spacecraft's instruments were specifically configured for this encounter. The microwave radiometer could probe tens of kilometers into the ice. The magnetometer could detect subtle variations in Europa's induced magnetic field. The radio and plasma wave instrument could listen for any emissions from the Moon's subsurface ocean. Then, at the exact moment when we needed NASA most, 200 scientists were quietly reassigned from Europa Clipper mission activities. Not furloughed, not laid off. Reassigned to other projects, their expertise suddenly needed elsewhere, their access to ongoing Europa analysis revoked. The official explanation was routine reorganization. Budget optimization. Nothing to do with Juno's observations. Just standard management decisions. Routine reorganization. Those words doing a lot of work to explain why planetary scientists with decades of Europa expertise were suddenly moved to unrelated missions precisely when the most important Europa data in years was being collected. Think about the timing for a moment. Europa Clipper, the flagship mission designed to conduct detailed reconnaissance of Europa, launched in October 2024. It's currently on its way to Jupiter, scheduled to arrive in 2030. The science team has spent years planning observations, developing analysis protocols, preparing for the most comprehensive study of an ocean world beyond Earth. And now, a significant portion of that team has been scattered to other projects. NASA's official website updated with standard mission status reports. No mention of unusual findings. No press releases about the Juno flyby results. The typical parade of scientists excited to share preliminary discoveries, absent. Radio silence in every sense of the term. Only essential personnel remained on the Europa Clipper team. A skeleton crew maintaining mission planning and spacecraft operations. But here's what makes it suspicious. The ice-penetrating radar instrument, Europa Clipper's most powerful tool for probing beneath the ice, had a major calibration test scheduled for early December. That test has been postponed indefinitely. No new date. No explanation. Amateur radio enthusiasts monitoring NASA's Deep Space Network traffic noticed something odd. During the days following Juno's Europa encounter, encrypted data streams from the spacecraft increased by 300%. Standard scientific data uses predictable compression algorithms and transmission protocols. The amateur DSN watchers can identify different data types by their signatures, even if they can't decrypt the content. What they saw after November 12th didn't match any known pattern. It looked like they were dumping raw, unprocessed data as fast as they could, one DSN tracker posted on Reddit. Like they wanted to get everything down before something happened to the spacecraft, or before someone decided to stop the transmission. Then came the congressional inquiry. Representative Maria Santos, who chairs the House Subcommittee on Space Science, sent a formal letter to NASA requesting information about the Europa observations. The letter, made public on her website, asked specific questions. What did Juno detect? Why have preliminary results not been released? Why were science team members reassigned? Has any data been classified under national security protocols? NASA's response, when it finally came 3 weeks later, was a masterpiece of saying nothing while appearing to answer. The agency confirmed Juno had successfully completed its Europa flyby. It stated that all data was being processed according to standard protocols. It noted that personnel decisions were internal matters. It assured Congress that no significant anomalies had been detected that would warrant security classification. Not a single specific finding was mentioned. Not one piece of actual science. Meanwhile, Dr. Lisa Cheng, a leading expert on Europa's subsurface ocean and a 15-year veteran of NASA's Planetary Science Division, was doing the media rounds. CNN, BBC, podcast interviews, anyone who would provide a platform. She laid out the scientific case for life in Europa's ocean with methodical precision. She explained how hydrothermal vents on the ocean floor could provide energy. She described the chemical pathways that might support microbial ecosystems. She emphasized the urgent need to search for biosignatures, but she never mentioned the signal. Not once. Not even when directly asked if there were any new reasons to suspect Europa might harbor life. She stuck to the established science, the peer-reviewed papers, the conservative estimates based on models and simulations. It was what she didn't say that was deafening. On a podcast with science communicator Neil deGrasse Tyson, Chung made an offhand comment that raised eyebrows among those paying close attention. Sometimes in science, she said, we discover things that require extraordinary care in how we communicate them. Not because we want to hide information, but because the implications are so profound that getting it wrong would be worse than taking our time to get it right. Tyson pressed her on what she meant. She deflected, redirected to talking about astrobiology in general terms. But the statement hung in the air. What discovery would require such extraordinary care? What implications could be so profound? There's a principle in signal analysis called the Knox criterion. When you're trying to determine whether a signal is artificial or natural, you look for specific markers: structure, repetition, information content, and improbability. One unusual characteristic can be explained away. Two might be coincidence. But when you stack 7 distinct anomalies on top of each other, the Knox criterion starts pointing toward design. Let me walk you through what makes the Europa signal unlike anything we've encountered from a planetary body. The signal operates at exactly 3.765 megahertz, stable to within 0.01%. Natural radio emissions from planetary magnetospheres, atmospheric phenomena, or geological processes show frequency drift. They wander across the spectrum as conditions change. This signal doesn't drift. Over the 30 years of sporadic observations, it has maintained the same frequency with the precision of an atomic clock. The only natural process that produces this kind of frequency stability is a maser microwave amplification by stimulated emission of radiation. Masers can occur naturally in space, typically in the clouds around dying stars. But they require very specific conditions: population inversion of molecules, a pump source, and an optical cavity. None of those conditions exist in Europa's subsurface ocean or ice shell. The probability of a natural maser forming in Europa's environment and maintaining stable operation for decades? Essentially zero. The signal repeats every 47 minutes with an accuracy of plus or minus 3 seconds. That's not Europa's rotation period, which is 3.55 days. It's tidally locked to Jupiter. It's not related to any orbital resonance with other Jovian moons. It doesn't correspond to any known geological cycle or ocean circulation pattern. Minutes is, however, suspiciously close to the time it would take a radio signal to propagate from beneath several kilometers of ice. Accounting for the signal's wavelength and the dielectric properties of water ice at cryogenic temperatures, if something were transmitting from the ocean floor and the signal had to penetrate varying thicknesses of ice depending on Europa's complex surface topology, you might see apparent periodicity as the transmission path geometry changed, but that assumes something is deliberately transmitting on a schedule. Natural radio. Emissions are typically broadband. They spread across a range of frequencies. Or they're narrowband but unmodulated, just carrier waves without information content. The Europa signal shows amplitude modulation with a complex structure. Dr. Rivera's analysis revealed at least 4 distinct frequency components within the main signal, each modulated at different rates. It looks like multiplexing, Rivera said in his preprint paper, like multiple channels of information being carried on a single carrier frequency. We use this technique in telecommunications because it's efficient. Nature doesn't optimize for efficiency. Nature is messy and redundant. Attempts to decode the modulation patterns have been unsuccessful, but that doesn't mean they're random. It might mean we don't have enough data, or we're using the wrong decoding scheme, or the information is in a format we don't recognize. But the structure is there, visible in the spectrograms, repeating with each 47-minute cycle. Every detection of the signal, from Galileo's observations in the 1990s to Juno's recent encounter, triangulates to the same general region, Terra Macula, a formation characterized by disrupted ice, possible cryovolcanic features, and evidence of recent geological activity. This is one of the most dynamic regions on Europa's surface. It's also directly above one of the theorized thinnest parts of Europa's ice shell, where the subsurface ocean might be only 1 to 2 kilometers below the surface instead of the typical 10-20 kilometers. If you wanted to communicate through the ice, this is where you'd do it. The signal is strongest when Juno or Galileo passed over Terra Macula, and weakest when observing from other angles, suggesting the transmission is directional, beamed upward through the ice. Natural radio sources like lightning or plasma oscillations would radiate in all directions. A directional beam implies an antenna, a purpose, an intended receiver. Dr. Marcus Webb's observation about the signal strengthening during specific configurations of Jupiter's magnetic field has been confirmed by analysis of multiple datasets. Europa orbits within Jupiter's intense magnetosphere, one of the most powerful magnetic environments in the solar system. The magnetosphere sweeps past Europa roughly every 11 hours as Jupiter rotates. During these sweeps, the Europa signal shows a 15–20% increase in power. It's as if the transmission is using Jupiter's magnetic field as an energy source, harvesting power from the very environment that makes radio transmission difficult. This is extraordinarily sophisticated if true, using ambient energy from a hostile radiation environment rather than fighting against it. No natural process known to science would exhibit this kind of synchronized response to external magnetic fields while maintaining coherent signal structure. Here's something that keeps researchers awake at night. Between Galileo's final Europa flyby in 2003 and Juno's extended mission beginning in 2024, there's a 21-year gap in close-up observations. We have Earth-based telescope data showing transient emissions, but no spacecraft data. During those 21 years, something changed. When Galileo detected the signal in the late 1990s, the modulation structure was simpler, essentially a pulsed carrier wave. When Juno detected it in 2024, the modulation had become more complex, showing the multiplex structure Rivera identified. It's as if the signal evolved, became more sophisticated, started carrying more information. Natural processes don't evolve toward greater complexity on decadal timescales. They erode, degrade, simplify. The second law of thermodynamics guarantees that. But the Europa signal is doing the opposite. Before the Arecibo radio telescope collapsed in 2020, it conducted limited observations of Jupiter's magnetosphere between 2017 and 2018. Dr. Vasquez's claim that similar patterns were detected and classified as difficult to verify. Arecibo's archives are incomplete, and much of the data from those observations remains restricted. But here's what we know. In 2018, Arecibo detected 3 instances of narrowband radio emissions from Jupiter's direction that couldn't be attributed to the planet itself or any of the other large moons. The detections occurred when Europa was in specific orbital positions. The frequency matched 3.765 mirrors. A planetary protection review board convened to assess the findings. Planetary protection protocols are designed to prevent biological contamination during space missions, but they can also be invoked when potential biosignatures are detected. The review board's conclusions are classified, which is itself unusual. Most astrobiology findings are published openly to encourage peer review. What was in those Arecibo observations that triggered a classification response? What did the review board conclude that required keeping the information restricted? 7 anomalies, 7 patterns that individually stretch the boundaries of natural explanation and collectively seem to point towards something that shouldn't exist. A technological signal originating from beneath the ice of an alien ocean.
Right now, as you read this, Europa Clipper is somewhere between Earth and Jupiter, traveling through the vast darkness of interplanetary space. In 2030, it will arrive at the Jovian system and begin a mission that could last for years. Dozens of flybys of Europa, each one bringing sophisticated instruments within hundreds of kilometers of the surface, each one designed to probe deeper into the moon's mysteries than any previous mission. The spacecraft carries 9 scientific instruments, but 3 of them are specifically designed to investigate what might lie beneath the ice. The ice-penetrating radar (IPR) can see through tens of kilometers of ice, mapping the internal structure and potentially detecting the subsurface ocean directly. If there's something at the ocean boundary generating radio signals, IPR will find it. The magnetometer will measure Europa's induced magnetic field with unprecedented precision, revealing details about the ocean's depth, salinity, and conductivity. Any large metallic structure or unusual electromagnetic activity in the ocean would create distinctive magnetic signatures. The surface dust analyzer will sample particles ejected from Europa's surface and any plumes of water vapor erupting from the ice. If there's biological activity in the ocean, or if there's technological debris of any kind, the dust analyzer might detect molecular signatures that don't belong. Europa Clipper will answer the question that's been building since November 12. Either the signal is natural, some exotic but explainable interaction between ice, ocean, and Jupiter's magnetic field that we simply haven't understood yet, or it's not natural, and the implications of that will cascade through every assumption we hold about life in the universe. But we won't know immediately. Europa Clipper's mission is carefully choreographed to build knowledge incrementally. Early flybys will characterize the surface and map the ice shell. Later, flybys will probe deeper, using the accumulated data to target specific regions for intense study. Terra Macula will certainly be a priority target, but it might not be examined in detail until years into the mission. That means we face a potentially long wait for confirmation or refutation of what Juno detected, unless something happens sooner. Let's explore both possibilities with complete intellectual honesty. First, the natural explanation. Scenario 1. It's natural. Europa's subsurface ocean is unlike anything on Earth. It's larger than all of Earth's oceans combined, contained beneath an ice shell that could be anywhere from 1 to 20 kilometers thick. The ocean is kept liquid by tidal heating. Jupiter's immense gravity flexes Europa's interior, generating heat through friction. That same tidal heating creates dynamic currents, temperature gradients, and potentially hydrothermal activity on the ocean floor. In this scenario, the signal we're detecting is a natural maser, created by a unique combination of factors. Metallic compounds dissolved in the ocean water, aligned by Europa's induced magnetic field, pumped by hydrothermal energy, and amplified through some cavity structure in the ice or rock. The 47-minute cycle represents a geological process we don't fully understand. Perhaps a geyser-like mechanism that releases magnetized water vapor into the ice on a regular schedule, creating a natural radio transmitter. The apparent modulation structure is an illusion, a result of how multiple natural processes overlap and interfere with each other. The frequency stability comes from the precise physics of maser action, which naturally locks onto specific molecular transition frequencies. The connection to Terra Macula is simply because that's where the geological conditions for this process happen to exist. In this interpretation, we're witnessing an exotic but entirely natural phenomenon, one that will teach us new physics about how ice worlds work but won't require rewriting astrobiology textbooks. It's weird, it's unexpected, but it's not impossible. Scenario 2. It's not natural. In this scenario, something in Europa's ocean is generating a deliberate signal, not life as we typically imagine it, not microbes or fish or anything biological, something technological, something designed. This requires accepting a premise that most scientists find uncomfortable, but can't logically rule out. That intelligence existed in our solar system before humans, that it built something on or in Europa, and that this technology has continued operating for an unknowable period of time, possibly millions or billions of years. The signal's characteristics: frequency, stability, structured modulation, directional beaming, synchronization with Jupiter's magnetic field all makes sense from an engineering perspective. You'd design a beacon exactly this way if you wanted it to penetrate kilometers of isoprate autonomously. For geological time-scale shortest energy from the environment, rather than relying on internal power be detectable by technological civilizations that develop radio, astronomy encode information in a format that resists degradation. Beacon hypothesis explains everything we're observing. It doesn't require exotic physics or improbable coincidences. It just requires accepting that we're not the first technological intelligence to exist in this solar system. And if that's true, if there's functioning technology beneath Europa's ice, then the questions become almost overwhelming. Who built it? When? Why? Is it a probe from another star system, or did intelligence arise in our solar system and leave this artifact behind before disappearing? Is the signal a message, And if so, what is it saying? Is it aware that we're listening? These aren't questions science is equipped to answer quickly. These are questions that would require direct investigation. Sample return missions, potentially even human exploration of Europa's ocean. These are questions that might take generations to fully answer. But first, we need to know which scenario is correct. Let's be honest about why NASA might choose silence over immediate disclosure, not because of conspiracy, not because of cover-up, but because of the sheer weight of responsibility that comes with potentially world-changing information. Imagine you're the scientist who definitively confirms the signal is artificial. You've checked your analysis 1,000 times. Your colleagues have peer-reviewed it. There's no reasonable doubt remaining. You now possess information that will fundamentally alter humanity's understanding of its place in the universe. Do you immediately tweet it out? Post it on ResearchGate? Call a press conference? Or do you pause? You think about what happens next. You consider the implications. Religious institutions will face challenges to foundational beliefs. Economic markets might become unstable as investors process the long-term implications of confirmed non-human intelligence. Governments will debate security implications, resource allocation, diplomatic protocols for entities that aren't human nations. The scientific community will need to develop entirely new frameworks for studying and potentially communicating with whatever created the signal. And there's a more immediate concern. What if approaching too closely or attempting communication triggers a response we're not prepared for? Planetary protection protocols exist precisely because we recognize our profound ignorance about biological and technological systems beyond Earth. If there's a functioning technology in Europa's ocean, what are the rules for interacting with it? Who decides? Who speaks for Earth? The silence, in this context, isn't cover-up, it's caution. It's the recognition that this discovery, if confirmed, is too important to bungle with premature announcements or inadequate preparation. But caution can't last forever. Europa Clipper will arrive in 2030. Its instruments will collect data that will either confirm the signal is natural or strongly suggest it isn't. At that point, silence won't be an option. The scientific community, the public, the entire world will demand answers. We're in a transitional period, the window between first detection and conclusive understanding, and windows don't stay open forever.
Early 2026 will bring new Juno observations of Europa. The spacecraft's orbit takes it close to the Moon several more times before its mission ends. Each pass is an opportunity to gather more data about the signal, to test hypotheses, to narrow down the source location with greater precision. Europa Clipper's arrival in 2030 will bring capabilities Juno doesn't have. Week after week of targeted observations, systematic mapping of Europa's interior, the ability to correlate surface features with subsurface structures. If the signal is real and consistent, Clipper will provide enough data to either explain it naturally or demonstrate that natural explanations are insufficient. And then comes the question of what to do with that information. If it's natural, we celebrate a new discovery and move on. If it's not natural, we face decisions unprecedented in human history. Do we attempt to decode the signal? Do we try to communicate back? Do we plan missions to reach whatever is generating the transmission? Do we involve the international community? Or does this become something handled by a small group of scientists and officials? These aren't hypothetical questions anymore. These are scenarios that scientists at NASA, ESA, and other space agencies are quietly beginning to consider. Not because they're convinced the signal is artificial, but because they know Europa Clipper will give us enough information to rule possibilities in or out. And if the artificial hypothesis survives that scrutiny, we'll need to have thought through what comes next. Right now, in November 2025, we're waiting. The signal continues its 47-minute cycle beneath Europa's ice. Juno continues its orbit around Jupiter. Europa Clipper continues its journey through deep space. Scientists continue their analysis of archived data, looking for patterns, searching for explanations, preparing for a revelation that might come or might never arrive. But the waiting won't last forever. One way or another, in the next few years, we'll know what's generating radio signals from beneath Europa's frozen ocean. we'll know if we're alone in this solar system or if something else has been here all along, waiting beneath the ice, broadcasting into the void, perhaps hoping someone would eventually listen. And we'll have to decide what to do with that knowledge. This is November 2025. The universe is stranger than we thought. The questions are bigger than we imagined, and the answers are closer than they've ever been. The signal continues, the spacecraft approach, and humanity holds its breath, waiting for Europa to reveal its secrets.